Okay, so this section 8.1 is in regards of polynomial functions and models. So let's take a look at a polynomial function, right? First, let's recall that we've learned many different functions. Right? We should know what a constant function looks like, a linear one, even a quadratic one. All right. We talked about polynomial functions as well. Right. These polynomial functions are in the form of, we can say, right, a function has to have f of x, right? Maybe something like ax to the power of n, right? Where a is just a real number. And your n is a positive integer. Right. Remember some of the polynomials that we looked at when it came into factoring. Right. We saw monomials. Right. Binomials. Trinomials. Right. Or it could be a polynomial. Right. So monomial would be something maybe like h of x equals, how about 2x squared? Binomial, something maybe like g of x equals 4x to the fourth plus 2x. Trinomial, something like g of x equals, I'll do a nice one, how about x squared plus 3x. What if we said minus 4? We should even be able to factor that if we wanted to, right? So you should be able to look at these polynomials and identify characteristics, right? And you should know what the difference between all of these are, right? So really quickly, let's take a look. Right, a constant. All right, how about we make ourselves a little table? Let's not forget it. We'll look at some examples. Constant, linear. How about something that's quadratic? How about something that's cubic? And then something that's quartic, right? An example of something linear or a constant is just a number, right? An example of something linear, right? All of a sudden we have a variable with no exponent, right? Quadratic, now it has that power of 2. Cubic, right? We'll have a power of 3. Quartic will have a power of 4. You should be able to, right, let's call this the type of function. Right, this is an example. You should be able to find the degree. This one is 0 because there's no exponent. This degree is 1 because, once again, that variable has no exponent. This degree is 2 because we clearly see it. 3 and then 4. All right, so the degree is just the highest exponent. Leading term. Now this is just the 3. Well, these are all 3s, right? So again, the leading term are just the numbers in front of the variable. There's no variable, so it's just a constant. I'm sorry, the leading term is that entire term. All right, so 3x, 3x squared, 3x to the third, and 3x to the fourth. And then the coefficient, right? This is the leading coefficient, is now the number. So these are all threes. All right, so some things that you should be familiar with, some nice review there. What you did in the past is you're able to work with a quadratic function, right? And what you're able to do with the quadratic function is you're able to graph it, right? Right, I give you f of x equals x squared minus 2x minus 3. Right, so if you recall, the first thing we need to do is find vertex. Right, vertex is in this xy ordered pair. And we know that x equals negative b over 2a. Right, we take a look, our a is 1, b is negative 2. C is negative 3. So this is just a negative 2 over 2 times 1. And that gives us two negatives, make a positive. All right. And that gives us 1. And then we can just plug that in to our equation. All right. And we get 1 minus 2 minus 3, which gives us what? 1 minus 2 is a negative 2. Negative 2 minus 3 gives us a negative 4. All right. So this tells us that our vertex is 1, negative 4. Also, a is positive, so we know it's going to open up. All right. So according to what we did before, this is 1, negative 1, negative 2, negative 3, negative 4. We have this point here. Right, we would just make a table. And we'd pick any x values that we wanted, right? Maybe something, this is 1 and that's negative 4. Maybe an x to the right, so maybe 2. Right, so y equals 2 squared. Oh, let me go back. All right, so we'll pick 2. So that's y equals 2 squared minus 2 times 2 minus 3. And what do we get when we do that? All right, that gives you a negative 3. So now I have another point, 2 and negative 3. And then you pick some number to the left, right? Maybe 0, right? So I pick 0. Y equals 0 squared minus 2 times 0 minus 3. That gives us a negative 3. All right, and then we can graph. All right. So this is something we did last time, right? You should be able to, with that, find your axis of symmetry. All right. All right, so it's x equals 1, your domain. Right, quadratic, we learned that it's always for a quadratic, negative infinity to positive infinity. And our range here, right, it's opening up. So our smallest y value is a negative 4 and includes it, and it goes up to a positive infinity. But we should be able to find some additional points here. How about we find... Let's go back to this problem. Let's find the x and y intercepts. All right, so let's start off with our x-intercept. All right, in order to find our x-intercept, our y's, in order to find the x-intercept, the y values must be 0. So then we have 0 equals x squared minus 2x minus 3. And you should be able to solve this, right? We can factor, right? This is a trinomial. Your leading coefficient is 1. So product factor is negative 3. That gives us negative 2. Would be what? Negative 3 times 1. That works, right? So 0 equals x minus 3, x plus 1, we get our answers of a 3 and a negative 1. All right, so x-intercepts are 3, 0, negative 1, 0. You should be able to find the y-intercepts. All right, when the y-intercepts, your x value is 0. All right, so we get y equals 0 squared minus 2 times 0 minus 3. Y equals 0. So we have 0. I'm sorry. We get negative 3. So we get 0, negative 3 as our y-intercept. All right, so now we know a lot more about this graph, right? We can graph this now. We found our vertex to be negative 1, negative 1, 2, 3, negative 4. And we have 1, 2, 3, 0, negative 1, 0. So we can graph it like that as well, right? So finding these intercepts is another way of doing it. Let's take a look at an example of a cubic, right? Let's graph a cubic function. So with this cubic, there is no vertex, right? There is no vertex. So we have no choice but, right? So there's no vertex. So we can't do it the way that we did the quadratic. So we must graph by either one, a table, or by two, by the intercepts. All right, but I think the intercepts is going to be the best choice because that lets us know how it goes up and down, right? Or if it goes the other way, right? Right, because if we recall, let's not recall that something like this, right, looks like that. So let's find the intercepts. Okay, and we have g of x equals x to the third plus 2x squared minus an 11x minus 12. Right, so we say 0 equals x to the third plus 2x squared minus 11x minus 12. All right, and what do we do here? We apply a factoring technique, right? And once we get it in a factored form, right, you should see that it's 0 equals an x plus 4 times an x plus 1 times x minus 3. So we have our x's being negative 4, negative 1, and 3. So our intercepts are negative 4, 0, right? Negative 1, 0. And then what else do we get? 3 and 0, right? These are our x-intercepts, right? And we're going to be talking about this later on in class. So don't stress on how I found this right now. This is something that I will teach later in the chapter. All right. Once again, do not worry yet. Okay, so now we'd find our y-intercepts, or y-intercept, right? So this time we get y equals 0 to the third plus 2 times 0 squared minus 11 times 0 minus 12. Our y here is negative 12, so we get 0, negative 12 as our y intercept. And because of the fact that our a is a positive, right, it's going to go in this direction, and these are things that we will also be talking about as we progress through our lecture. So my intercepts are negative 1, negative 2, negative 3, negative 4, 0. We have negative 1, 0, 1, 2, 3, 0. So it looks like it will go like this, like that. My y-intercept is 0, negative 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to come down, hit this point, and then go up. So a very nice graph, and these are things that we will be discussing throughout our chapter, right? So let's talk about how we can start determining these things. First, don't forget your domains, right? You need to make sure you know your domains of all your functions, all right? Which means it doesn't matter what example I give you, you should be able to find any domain and also look at characteristics, right? So always know your domains, okay? Right, anything that's what? We talked about them, linear, quadratic, cubic, right? Absolute value, right? Just to name a few, are always negative infinity, positive infinity. And we're talking about polynomials, so we'll just kind of stress on that. Okay, let's take a look at the leading term. Right, so what the leading term tells us is that if we have an even leading term, right? If we have an even leading term, all we know is that our graph can go like this, right? We don't know what the middle is, or can go like that, right? This is telling us about the end behavior of a graph. So we don't know what's happening in the middle, but we know it's going to go like this or like that, right? It opens up if our A is positive, opens down if our A is negative. And if our n, our leading term n, is odd, then it's going to go like this. We don't know what this is, and it'll go like that. Right? If it's odd and it's positive, it looks like that. If it's odd and negative, then these are our end behaviors. Right? So it's important to understand that. Right? I mean, we take a look at an example. Right? We want to look at, let's just say, the end behaviors. Let me see if I can find some nice examples. And we want to find the end behavior of, how about f of x equals negative 3x to the third minus x plus 4. Well, our n is odd, our a is negative, so odd, negative, tells us it looks like that. right? Our n is an odd number. Our a is negative, so that's going to be our end behavior. Right? So our graph is going to go something like that, and it's going to end something like that. Example B. F of x equals 1 over 4 x to the 4th plus 1 over 2 x to the 3rd minus 6x squared plus x minus 5. This is even. This is positive. Right? So take a look at the table. Even, positive, it's going to look something like this. So the end of our graph will be like that. The end of our graph will be like that. We don't know what's going to happen in the middle. One more example. How about f of x equals negative 3.5 x to the 4th plus x to the 6th plus 0.1 x to the 7th. Well, this example, we need to reorganize our terms. All right, we always want to show the greatest degree first. So now this is odd, this is positive. All right, so back again, odd, positive is going to look like that. All right, so this tells us, once again, the end behaviors. All right, this just tells us our end behaviors of a graph. Okay, but now what we want to do is we actually want to take a look and let's talk about something, because we always use the term x-intercepts, but x-intercepts are also called zeros of an equation. Right? So I can ask you to find the zeros of g of x. And I tell you that g of x equals x squared minus 2x minus 8. All right, so once again, the zeros is just the x-intercept. And we know when it comes to the x-intercept that y equals 0. So it's just 0 equals x squared minus 2x minus 8. And all we're doing is solving here, right? We factor. Product of negative 8, that sums to give us negative 2. Right, what do we get? Negative 4 times 2. Right, doesn't that work? So it's 0 equals x minus 4, x plus 2. We get these answers to be 4 and negative 2. So our zeros here are what? 4, 0, and negative 2, 0. We can always check to see, is the given number a 0 to the function. All right. How about example A? Is 4 a 0 to g of x equals x squared minus 2x minus 8. So all we have to do is plug 4 into x, right? Plug 4 into x. And does that give you 0? You'll notice that it gives you 0. So is 4 a 0 here? We can say yes. And I mean, we saw it up here, right? Once again, when x is 4, y is 0. And that's what that means. How about our next example, B? All right, is 2 a 0 to p of x equals x to the third plus x squared minus 17x plus 15. So we replace again, and we're just checking, is it 0 or not? 2 to the third plus 2 squared minus 17 times 2 plus 15, all right? Does that give you 0? So 2 to the third plus 2 squared minus 17 times 2 plus 15. We see that this gives us -7, so we can say no, all right? So easy way to check if numbers are zeros or not. All right, how about I ask you to find the zeros of, this is a nice example, f of x equals 5, open parentheses, x minus 2, close parentheses, x minus 2, close parentheses, x minus 2, close parentheses, x plus 1, close parentheses. It's in factored form, so we learned that we set each thing equal to 0, right? Each factored form equal to 0. And we solve. There we can't. There we get 2. There we get 2. There we get 2. And there we get -1. All right, these are all the same, so we only show it one time. All right, so our zeros here are all right. What about our next example? We get x to the third minus 2x squared minus 9x plus 18. All right, so we set it equal to 0. All right, so some nice review here. Polynomial with 4 terms, so we should do factor by grouping, right? GCF here is x squared. That comes out. We're left with the x minus 2. GCF here is a -9. That comes out. We're left with x minus 2. So now we can show it in our factored form. All right. But this we can still factor, right? We can square root that. We can square root that. So that's x minus 3, x plus 3. We bring that down. So what do we get? X to equal 2, x to equal 3, and x to equal a negative 3, right? Don't forget here, because of the fact that this has a power of 3, all right, should tell you that you should get 3 x values, all right? That's always a nice clue. Most of the time, not always, but most of the time. Next example here, find zeros. F of x equals x to the 4th plus 4x squared minus 45. This is a trinomial. Our a is 1. So we have a what? A negative 45. That gives us 4. That'd be a what? A 9 times a negative 5. That works. All right, so these have to be x squares. But here we see, no, we can't do anything there. We can't factor. These are both non-factorable. But we did learn a different way to solve these, right? We have x squared plus 9 equals 0. X squared is 5. This is what you did on your last chapter, and you just took a test on that, right? So this is x squared equals, we subtract 9, we get negative 9, right? This is x squared equals, we add 5. Right? We do the square root of each one of these. All right? So we get x to equal, this gives us an imaginary number, right? This is negative square root of 9. So this is x equals, what do we get? Plus or minus 3i. All right? So we can see the importance of understanding your last exam. All right, we square root over there each side. And here, we can't really do anything, so we get x equals plus or minus square root of 5. Once again, power of 4, right? So 4 zeros. We have a positive 3i, a negative 3i, a positive square root of 5, and a negative square root of 5. And you really don't have to show this. All right, so... So some nice examples in this 8.1 section. If you have any more questions,